Hey everyone, doing this video again, so hopefully the audio is a little bit better. So again, what we're doing is it's systems of equations, and you have thus learned, or so far learned, three different ways to solve graphing, substitution, and elimination. And we do want you to be able to do each one of these when asked. However, when you don't have to use a particular method, then you get to decide. And so this is a little like explanation of when you want to use each one or when it's in your best interest so that you can start identifying when to use each type. Now, you could do any method for solving, but sometimes it's not the easiest route. It's just what I call the scenic route because maybe it takes a little longer, but you end up there in the end. Okay, so let's start with graphing. So for graphing, um, a good time to use it is when both equations are in slope intercept form, obviously, because that is a very, very easy way to graph, right? So if they're both already in slope intercept form, like here and here, then you can just graph and you're good to go. If you've forgotten what slope intercept form is, I put a little arrow down here for y equals mx plus b. Okay, also super helpful if you have graph paper. Now, sometimes you just get really lucky when they look like this, but if they don't, another good time to use graphing is if both equations, y terms, so the terms that contain the y, have coefficients of 1. Okay, so if we look down here at my example, here, this, and this, you go, oh, those don't actually have coefficients, but they do, and that coefficient is 1. Remember, if you can't see it, the coefficient is 1. And the reason we like that is because then it is easily put into slope intercept form. Okay, it's very easy just to rearrange this because if there's a number in front of y, you should know if you solve for y that you'll have to divide everything by that number in the end. But here, since it's already a 1, you just have to move this x term over and this x term over. So remember, I would prefer that you do it and show your steps, but since we're just talking about what things will look like, what happens is you solve these for y, and hopefully you trust me that they end up being y equals negative x minus 1 because you would subtract x from both sides, and y equals negative 5x minus 13 because you subtract 5x from both sides. And now they're in slope intercept form and you are ready to graph it. And then lastly, even if you don't have the first scenario or the second scenario, that doesn't mean that if you love graphing, you can't do it. But some things to think about is you can solve each equation for y, because that's what gets it in slope intercept form. But you want to make sure that you have whole numbers for the y-intercept, because if you have fractions and you have to do the y-intercept at like 7/8 and then go up 9 over 2 from there, that can be really difficult, especially if you don't have graph paper. So I would just avoid it. If you solve for y and you get a fraction for y-intercept, that's not great. The other problem is that you might solve for the y-intercept, and the y-intercept that are not too big. If you solve for the y-intercept and you get really, really large numbers like 100, then you have to draw a really big graph, and that's not great. Okay, especially if the y-intercepts are really far apart from each other. If one is 100 and one is -4, then your graph has to be really huge to compensate. In addition to that, it's going to probably be a really weird place that they cross that you'd have to make a really big graph for it. So you want y-intercepts that are not too big, and you want them to be whole numbers. And then lastly, even though you don't want the y-intercept as a fraction or a decimal, you do want to leave slope as a fraction, because remember that tells you whether to go up or down and then to the right. Okay, if you put it as a decimal, then that is not as helpful for graphing. So in this case, when we look here, you have to remind yourself, okay, what am I going to be solving for? So this one's already y equals. We're good to go. This one is not. But if you notice, the coefficient of the y is -3. At some point when you're solving for y, you'll move this over and then you'll divide everything by that number. And look here, we know that we're not going to have any issues because these two numbers are divisible by that one. So that's a quick way to check before you actually go through this, the steps to solve is by looking at this and saying, okay, if I divide everything by this number, will I end up okay? Now remember, the number with the x, you can leave that as a fraction. So that one's not as big of a deal as this one. This will end up being your y-intercept. So notice here that this divides evenly, and that divides evenly into this number and this number. So again, just a quick way to check to make sure that when you solve, you're going to have nice numbers in the end. Okay, so those are when you want to do graphing, or when it would be a good choice to use graphing. Then we have substitution. Now again, you will have your favorite. Substitution happens to be my favorite, but that doesn't mean that sometimes I don't use elimination and graphing because it just makes more sense. But when we do a substitution, so the first step for substitution is to take your equation, one of them, and solve for x or y. So if one equation is already solved for x or y, then you're good to go because the first step is already done for you. So when we say that they're already solved for x, that would mean that one equation is equals. Not 3x equals, not negative x equals, just x equals. And if it's solved for y, then that means y equals. Again, not negative y, not 12y, just y. Now, you want to do this especially if solved for x. Now, the reason I put this in here is because if it's solved for y, you could use graphing, right? That could be a road you could go down. But if something is already x equals, you would have to rearrange it to graph it. X equals, you would have to do some rearranging when we get down here and you'll see why. So if it's x equals, really the best place to go is substitution. So if one is x equals, I automatically do substitution every time. So here, when you look, this bottom equation is already x equals. So you're good to go because you can take this here, the thing x is equal to, and go and plug it in to the other equation in for x. I don't have to do anything else very special. I don't have to solve. It's just good to go. All right. Now, that's not always the case, that it's already x equals or y equals, but just like up here, if a coefficient is 1, we've determined that it's easy to solve for. Okay, if the coefficient of anything is 1, boom, easy to solve for, and you can rearrange. So if any variables have a coefficient, sorry, I know the paper's moving around a lot, of 1, then you're going to want to solve for that and you're set up for substitution. And as opposed to up here where it had to be y, here it can be any variable from either equation. I just need 1, and actually that ends up working out here. See, this one has a coefficient of 3, -3, -3. This one just has a coefficient of 1. So we've got this guy here, and we have coefficient of 1, and that means that it's easily solved for. So again, I'm not going to show you all the steps, but essentially you can solve really easily just by moving the 3y over, and you do that by subtracting the 3y. So you end up with x equals negative 3y plus 1. And now that you've done that, really simple and easy, we take what x is equal to and put it into the other equation. Don't put it back into the first equation because you'll get 0 equals 0. You want to put it into the other equation. So again, if any of the coefficients are 1, that's good. You're right set up to do substitution. And then again, lastly, just because these first two don't line up, you still can use substitution. And that would be if any variable is easily solved for. And so again, when I say easily solved for, it means that we want to make sure that we are bewaring of fractions and decimals, because if you have fractions and decimals when you solve, then you have to do more math with those fractions and decimals. So I'm not saying it's not doable, I'm just saying that it's not necessarily easy. And secondly, I just wanted to stick in there that we do need to be aware of distributing negatives. So for example, here, when I put this in, you're going to have negative 3 times all of this. So do make sure that you distribute that negative to both the negative 3y and the negative and the 1, okay? Because I just want to stick that in there. It's a big place where people make mistakes. But like I say here, look, I know that this one has a coefficient of 1, so this would be the easiest thing to solve for, but I couldn't find a really good system for this. But let's pretend down here instead, we're looking at just this one equation. And I'm asking myself, would it be easy to solve for either x or y? So just kind of like up here where I was looking, are all of them divisible by the same thing? I'm going to look at that same thing here. Notice that this 6 and this 12 are both divisible by 3. That means if I solve for x, it's not going to be that difficult because it will go in evenly to this number and this number. So again, that's a way that you can check to see if it's going to be easily solvable. Whereas if I tried to solve for the x up here, I would have to divide 2 by 5. And I know that I'm not including the negatives, and that's just because the sign switches. There's no actual difference in whether or not a number goes in evenly. But 2 divided by 5 is 0.4. Okay, then I have to deal with a decimal. So it would be easier to solve for this negative 3. So we would say that this is easily solved for because the negative 3 is going to divide evenly into those. So let's just write ourselves a little note so we know what in the world we were thinking. So we would say, you can easily solve for x because the other numbers in equation are divisible by negative 3. Okay, and that's the big thing that you go, oh, everything else will be divisible by that. I know solving for that's going to be easy. It doesn't mean, again, that you can't do it. It just means that it's not going to be very slick. All right, so now I've gone to kind of the catch-all. So when you're doing those ones, there's a lot of like things that will make it easier. Otherwise, it can get pretty complex. But down here, almost everything will work for it, but I kind of use it more as a last resort. But again, remember that you'll be asked specifically to use elimination sometimes, and you'll want to know when is it the best time to do that. So for this first one, it is a good time to use elimination when both equations are in standard form. And if you do not remember what standard form is, again, I put this arrow that comes down here. That's ax plus by is equal to c. And so notice that the variables are all on the left in alphabetical order, then the equal sign, and then c. So the reason that if they're both already set up for this, it's great just to use elimination because everything's already lined up. The x's, the y's, and equal signs, and the numbers. So what we're going to say is that that everything is lined up. Okay, and then in addition to that, we don't have to solve for x or y first. So if I wanted to graph this, I would have to solve both of these for y. It'd have to be y equals and y equals so that they're both in slope-intercept form. If I wanted to use a substitution, then I would have to take one of these and solve for x or y. Just one, but still not necessarily the easiest. Here, this one could be okay because 6 and 6 are divisible by 2. But I wouldn't want to divide everything by 6 necessarily here. Here, if I wanted to solve for x, I'd have to divide everything by -7 at some point. 8, not divisible by 7. 5, not divisible by 7. So the good news is here, you don't have to solve for anything. You multiply by some number. So the numbers might get bigger, but at least you won't have fractions. Okay? So that's why if they're already like this and there's no coefficients of 1, it's kind of like, let's just get rolling. Okay, another good time to use elimination is if the coefficients for the same variable match. So if I'm looking at the two equations and I look at the x's and the number in front of the x's are the same, that's good. Or if I'm looking at the two equations and I look at the y's and the number in front of the y's are the same, that's good. And for this case, what I would do is just go ahead and ignore whether there's a plus or a minus, because you can just multiply the whole equation by -1 to fix that. So that's not a very big deal. The big deal is that the number itself is the same. So if we look down here, we can see that our x terms both have a 3. I know that the y has a 3, but that doesn't matter because it does not match the 4. Now notice that they are not in standard form because this one has a y on the left and x on the right. So they're not in standard form, but these guys do match, which means when we rearrange, and again, I would show the work. We'll be subtracting that 3x over. So it's -3x minus 4y equals 2. And the bottom equation stays the same because it's already in standard form. And now notice that these will be ready to add to 0. Again, you may have to multiply by -1. So let's give ourselves a disclaimer so we remember that. May need to multiply by -1. Okay, and again, that's just to make these signs be opposite, because if they were both -3, they would add to -6. If they were both +3, they would add to +6, and that's not good. If nothing eliminates, why are you using elimination method? So, but if the number themselves, that's like half the battle, so that's great. But then again, put them in standard form so everything lines up. And then lastly, it's kind of a lame reason, but you would want to use elimination when no other method is a good choice. It's kind of like one of those really lame arguments. It's like, well, do you have a better option? It's like, well, no, I don't. So, okay, I agree with you. So a good way to find out is if there's no other good option is you ask yourself, okay, well, oops, sorry again about moving the paper. Does it have slope-intercept form? So are either of these y equals mx plus b? No, they are not. So that means it's not good for graphing. Does it have x or y solved for? Is it already solved for x or y? Is either of these x equals or y equals? No, they're not, which means it's not a super easy one to use for substitution. Are any of the coefficients 1? Well, if we look up here, we have 2, 7, -5, -8. No. Remember, the reason I'm looking for coefficients of 1 is because that's the easiest way to solve for a variable, is if its coefficient is 1. So again, that could get me to substitution or graphing. And then lastly, a variable can be easily solved for. Well, here it is 2x, so I could divide everything by 2, but notice I'm going to get a fraction here and a fraction here. Also, if I try to divide things by 7, that's not divisible by 7, that's not divisible by 7. Same thing will go if you try this. If I try and solve for y, I'll have to divide everything by -8. That's not going to help. If I want to solve for this x, I'll have to divide everything by -5. Again, not a good choice. So because I don't see anything above where, like here, all of these numbers were divisible by 3, it would not be a very slick way to solve for a variable. So no. So because none of these are good options, you want to go ahead and just use elimination, because here it will create a little bit of a nightmare if you try and use graphing or substitution. So you just use elimination instead. All right, I hope that this helps you when you are making decisions about which method to use. If you have any questions, of course, email us. And I hope that the audio is better. All right, have a good day.